So I'm going to show you an example of how to use the delta epsilon definition to prove that a limit exists. So I've chosen a linear equation, f of x equals 2x plus 5, and I've chosen an a value of 1. That's just any arbitrary x value. And then my limit L would be 7, and the way that I got that was just putting in x equals 1 into this function and coming out with the answer of 7. Okay, so that's where all of our values are coming from. So in order to use the definition to prove that this exists, and also to play along with the game that's outlined in the assignment, what we're going to do first is we're going to kind of line up side by side the delta and the epsilon according to what we understand from the last video in terms of what values those are. So the delta is just any x value minus a. So it's just the little bit that we're going to change our x value that we're given along the x-axis in order to get the new value of y, which is the epsilon value that we're choosing. So the epsilon value is defined as f of x, which is the function y, minus your limit, because epsilon is just the difference between any y value of the function and that special number, in this case 7, which is our limit. We're going to choose to be just a little bit more than the limit or a little bit less than the limit on the y-axis, and that's what epsilon is doing. So here we can fill in our a value. We were given 1 for a in this example. And here we can fill in our function 2x plus 5 and L, which is 7. Now, there's not too much we can do with this function here. It's already pretty simplified. But if we look over here at the epsilon function, we can collect up our constants. We can common factor. And we could even write the left-hand side so that it's exactly the same as the delta definition. So if the two left-hand sides of these equations are equal, then the right-hand side also have to be equal. And so what that allows us to do is to conclude that in this example, as long as I choose a delta that's epsilon divided by 2, or 1/2 of the epsilon value, or smaller, that this definition will always be true. And so that proves that our definition, the epsilon delta definition, proves that our limit exists for this function. Now let's talk about the game for a second, okay? The game, if we, let's go through an example of how this game is going to work. All right, now for this function, just going to move all that off there. For this function, the player A, okay, we've said, I'm just going to write this here again, that delta should always be e over 2, epsilon over 2, okay. So for this game, what I'm going to do is in the first step, it says that A moves first, picking a small number epsilon that's greater than 0. And so I'm going to pick a small number. I'm going to pick epsilon to be equal to 0.5. So I want to be within 1/2 of the limit on the y-axis. So I'm either going to be 7.5 or 6.5, which is 1/2 under that limiting value, okay? So now we're going to have player B come along, and player B is going to pick another smaller number, delta. But he's already done the definition work that we did above, and he knows that as long as he chooses a delta that's smaller or equal to epsilon divided by 2, he's going to win this game. So he's going to choose a delta of 0.25. Now, according to the instructions in the game, in the third step of the game, player A comes back, and he's going to choose an x value that's within delta, in other words, within 0.25 of our A value. Remember, our A value is 1, right? Here's our A value right here. And so he's going to choose an x value that is either 1 minus 0.25, which would be 0.75, or 1 plus 0.25, which would give us 1.25. So what that does is it gives us a range for the x value that we can choose. We can choose anything in between those values. We're going to choose that x value and we're going to put it back into the function. We're going to put it back into 2x plus 5. And the way the rules are set up, it says that if we get an answer that is within epsilon of our limit, so let's make that makes more sense. If we get an answer that's, because our epsilon was 0.5, if our answer, if our f of x answer is less than 7 plus 0.5, or greater than 6.5, which is 7 minus 0.5, then player B wins. If not, then player A wins. And so all we need to do is pick a value in between those two values and put them into the function and see what value the function is going to give us. So I'm going to choose a value of 0.8. So if I choose, let's let x equal 0.8, because that's right in between, that's bigger than 0.75 and less than 1.75. I'm going to put that into my function, f of 0.8 equals 2 times 0.8 plus 5 equals 1.6 plus 5 equals 6.6. So when I go back over here and I check, it did land in between 6.5 and 7.5. So therefore, player B wins. And you're going to find that any value that you choose between these two values is always going to land, give you an f of x value or y value in between these two values. So player B will always win as long as he chooses his numbers between those two x values. And that's the idea behind playing the game and understanding the delta epsilon definition of the limit. So that should help you get started on question 1. You should also, I think, be able to understand question 2 a little bit better. Give it a try, and later on there'll be a second video to help you get started on that one also.